Hi there. So I'm back here in. Just realized. Okay. Right. Hi there. I'm back in uh, in my live stream. So I'm continuing my work on training a machine learning model for image classification. In this case, we're training images coming from a wildlife camera. So I need to detect what kind of animal is in the picture. So yesterday I had to add some code to square the images without cropping, because the problem I had yesterday was that when training the model with the and the, because the actual in this case I'm using MobileNet, and MobileNet requires images as squares. So we need to so the typical way to deal with that is to just crop the images, like crop at the center and lose the edges. But that doesn't work if the subject you're trying to detect is at the edge of the image. So that's why basically I had to find another way to deal with that. So instead of just cropping, I added some code to add black bars at the top and the bottom, or at the left or right, depending on what kind of aspect ratio the image has. Okay, so let's just run this notebook again, just to make sure that we are back to a place where we were yesterday. So I have this method here, which was inspired heavily on what I found on the internet, to be honest. No need to reinvent the wheel. So this uses OpenCV, checks the aspect ratio of the image, and then resizes it. And then if there's any if the image doesn't fit into a square, then it will add the padding. Not much to say about it. Then what I did, I changed this method copy files. This is copying images from the dataset, which is an input, right? I'm copying it to this Kaggle working directory, okay? And the idea is, well, the original idea of the copy images, the copy files method was to just control how many images I have, because I wanted to have some balance between image classes. I have 3 in this case. I have foxes, cats, and birds. I have only just under 500 foxes for my data set, the training and the validation, and then I have almost 4,000 images for cats and 4,000 images for birds. So that was, of course, there is a lack of balance there, right? So that's why I created this method copy files to prevent that from happening. No, because I'll be curious. Okay, so I don't know why every time, the first time I run this, it always gives me a syntax error, but there's nothing wrong with it. Okay, so I'm going to copy the files, and at the same time, this is going to square the images. Okay. these are, I'm only working right now, I'm only copying the training and the test data set, right? No, the training and the validation data set. I haven't done yet the testing, so maybe I'm also going to include, yeah, this is actually the most important, right? So I'm going to square these images as well, so I need to make sure that I iterate for all the directories I need. So this is doing copy files for the training and validation, right? Which now it's going to be a bit, maybe I'm going to rename it because I'll have to merge both data sets at some point. Okay, I'm going to call it dataset okay, I'm going to call it internet. So because these images are coming from the internet, it's nothing to do with my camera, yeah? And then I'm going to create another method here called copy files, and I'm going to copy the, I need to review all these names anyway, because it's no longer going to be just for testing. So my images are going to be used for more than that. So these are my own images actually. So dataset pi. I'm going to call it pi. So images from my Raspberry Pi camera. Right now I only have like just under 100. Yeah, and these are images from the internet. Okay. And what I found yesterday is that if I train on this data set, you know, both for the training and validation data sets, if I use only images from here, I get terrible results when I actually evaluate against my test data set, which are the images from my Raspberry Pi. So one thing I tried as well was to use some images, instead of using the validation data set from here, I use the validation data set from my own images, yeah? But then I realized that I have a problem with my images, which is more noticeable than what you would notice in these images here, right? Most of the times my subject is not in the center, right? So my birds, the birds I capture, sometimes they are going to be at the edges of the images, depending on, yeah, depending where they are really. And the cats and the foxes, they'll be anywhere as well. Okay, right. So I'm going to run this. So now I have two directories. Okay. I need to revise these names. This is too long. It's no meaning. So dataset reduced. It's just weird. What happened there? Square image with padding instead, right? I ran this, right? Okay, I try it. Let's try again. So, okay, now it's copying. And I should have the directories created here. I need to review those names though. What I'll end up doing, I'll create a new version of my dataset and I'll make these names a little bit more generic. Okay. So all the images should be squared properly without cropping. And let's just count how many we have. It's probably going to fail, right? Because I changed the directories. So now I have dataset reduced. Raspberry Wi-Fi. Okay, internet. Yeah, so these are the images gathered from the internet, different sources, and these are images gathered from my Raspberry Pi, which is going to be quite less. Yeah. So if we're going to use this dataset for anything more than just testing dataset, we need to increase the number of pictures for sure. So I need to deal with that later. Right, so now I can't. Okay, the camera. So internet. Okay. So you can see the black bars now. Because yeah, the thing about these images is that in general they have been taken. They are pictures taken by a photographer, right? And they will normally center their subject in the center, right? They'll make sure it's in the center. So that's why cropping these images in general wasn't an issue. And now I'll copy and paste this cell, create another one, and you can see the difference. Yeah, right, you see if I had cropped this picture, this fox here would have been lost, or maybe not, but like it's probably not best example. Let me try another one. So 1, 2, yeah, you can so even this picture, which is not cropped anymore, yeah, it's here. This is a cat or something like that. Okay. Okay, so now there's no cropping, there's black bars, which is okay. And just going to run through this notebook. I don't know about this. This is quite annoying, this error message. Probably should do a search on this and see what this is. Maybe I can just resolve this and makes it a bit cleaner. Wow, 69,000. So everyone is asking about TensorFlow 2.6. Okay, so we're not supposed to be using it, but it still shows a very annoying errors, and I don't like it. So let's see what this means. So I want to get rid of this message if I can. Okay. So let's do that. So if I set the logger to info, it should make this annoying debug disappear. Okay, I can do it somewhere here. Okay, so now I'm hoping, well, I still have too much debug there. So let's run this again. Maybe a restart. Maybe a restart will do it. Let's see. So let's hope that the debug is gone now. No, still going. What did I do wrong? Didn't work. Okay, maybe I'll deal with that later. No big deal. Okay, I can see. So this is a sample of our data set with the actual ground truth labels, yeah? So what you're seeing here is the actual, what was supposed to contain the image. So we can see birds here. It's a bit hard to see, but it's tiny images. I'm just gonna try 50-50 or something. Yeah, much easier, right? Okay, I'm making good use of my screen now. So this is a bird, cat, fox, two fox, bird. What is this? It's supposed to be a cat. Can you see the cat here? So I need to clean this up now. There's no cat. The fox, bird, fox, and then cat. Okay. Okay. So we're loading the datasets. So the images should already be with the correct dimensions. Okay, it's gone. Right, so now, okay. Now this is the section to read the model that we're going to use as our base model for the transfer learning. NumPy is, I don't understand, some random errors happen here. It's probably a bug in Kaggle because I never seen this in another type of notebook, right? It's not reading the whole stream here for whatever reason. Okay, now we are just evaluating just downloading the model itself and the weights. Okay, building the model with we're adding a dense layer with three, in this case 3 neurons, one for each label that we want to identify, fox, cat, and birds. Then we have the prediction layer is the global, it's the, what's the prediction layer? Prediction layer is somewhere here. So prediction layer is here. It's the 3 neurons, which we were discussing just now. So we have a dropout. This is for regularization, to make sure that our model doesn't memorize everything. So we are dropping basically neurons from each layer. Then the global average layer, this is a global average pooling. And then this is the actual model. This is the MobileNet model. We don't update any of the weights, and we remove the last layer, which is the classification layer that can detect like 1,000 classes, but we don't need it. Okay, now we are defining here the learning rate. This is how fast we are shifting all the weights every time we do a new training iteration, an epoch. Okay, did I run everything? Okay, now we do just an evaluation of the model before we do any transfer learning. It should do terrible. Okay, so accuracy is, it's actually not too bad. But we are using the validation dataset, which is already going to do quite well, because it's not too different from what I think the ImageNet datasets and the dataset I gather from other sources. They are quite similar. They are actual photos that are taken by someone, a human person, right, who makes sure like for example the fox is nice and big and it's in the center of the frame. So this is why this is going to do quite well. Okay, if I evaluate, and this is a result which is quite impressive, taking into account we haven't even done any transfer learning yet. Yeah, this is the model with just the default weights, which is quite good. Okay, if I test, if I change this to use the test data set, which is from my Raspberry Pi camera, oh, I haven't defined it yet. I'll show it later. Okay, so now let's do the training, and this error is really annoying. I need to fix that. I thought I had a fix, but this guy didn't work. Oh. So there's a problem with my TensorFlow maybe. Which TensorFlow version I'm using? There's an API call, I don't remember what it is, but it will tell me what version it is. Okay. So this is a bug. Oh, 2.6. Okay, so yeah. I think I'll have to leave it with it for a while. Don't spend too much time trying to upgrade this. Okay. Shouldn't affect the results. You can already see, right? This is not doing very well. When it did. Don't know how many epochs he has done. I think already. So 10 epochs. So it's interesting because the validation accuracy is actually quite low. I don't know what happened there. So something went wrong. You didn't like the black bars? Oh, sorry, it's using my... Hang on. So this code is already using my dataset as the validation dataset. So that explains why the results are so bad, right? Because yesterday I tried to swap I swapped the two datasets. Okay, so the train dataset. Okay, yeah, I'm using the pi, but the problem I have, right, I can't just use the train dataset from the pi for now because I only have like less than 100 images. So for now, I'm going to leave it as the camera, as the internet dataset from the internet. Okay. and the results should be much better. Okay, this is, so we're loading the data sets again. I'm building the model. So you can see the accuracy goes up very quickly. So both for so there's two types of accuracy here. You can see the accuracy on the training data set, which is the data set that is being used to actually learn. So the model is looking at these images and learning from it. And the validation accuracy and the validation loss, these are numbers, losses calculated from the validation data set, which the model doesn't learn from directly, right? But all the weights and all the hyperparameters that we pick at the end of each epoch, they are based on these two losses, right? These two losses will guide that to some extent. Okay. You can see all the labels look more or less okay. The results are pretty good, even with the black bars now, right? So the black bars are not an issue. At least we can determine that. And now we have our taste dataset, which is from the pie. So I need to use this one. And I can actually test with the black bars and see if the validation is okay. If it evaluates well. At this stage, the pi dataset it wasn't used for the training or the validation yet. Okay. You can see okay. Let me just make everything bigger. Strangely enough. The images are not different. I didn't have the noise removal on. Sorry if there was a lot of noise there. So I'm going to make this a little bit quieter. Hopefully the next train won't make a huge bang. Can you hear me properly? I hope so. All right. This is a fox. Okay, in general, these labels are wrong. Okay, this is a bird. Okay, so what I can do now, I can just create a new cell. I'm going to add a key. I'm going to swap. Actually, I don't even have to do that. So I can do the validation data set is equal to the testing data set, right? Then I'll make sure that the model I'm training is again from scratch. Copy this again. I can give different names as well to the models just to make it easier to compare. But I'm not going to do that for now. It's okay. So run this. Testing this. Yeah, it's there, right? So I can just so I'm using my Raspberry Pi camera photos for the validation dataset, and this time it has black bars instead of cropping, so all the images are perfectly square and we don't lose anything in the images. There's also but that's still the case that I have one image or two that have that I need to fix. The problem I definitely have is that I have a very small number of images. I need to have more, but for now let's just give it a go and see what happens. It's hot. Okay, so we have a loss of the accuracy is normal, that it goes up very quickly, but the validation, okay, validation accuracy this is the number that we care about. This one and this one. They both seem to be, they're not going anywhere, which means, yeah, so I still need to do more work on it. So the model itself hasn't learned. Okay, so I know by looking at these two numbers, I know that my loss is too high and my accuracy is too low. And this is the accuracy on my validation data set. And by doing 10 epochs, I was able to see, okay, you don't have to train this for too long, right? I'm just training it for a little bit of time to see if there is any kind of notable improvements. And there isn't any. In fact, it gets worse. This is not even for the validation data set. Okay. Right. So we need to come up with a way to improve these results. And the more obvious way that I've already solved the problem with the cropping. I probably need to do some cleanup of the images, which I can do quite quickly, to be honest, before I gather any more. So if I go here, okay, I think this is the. So we have some images here without the actual subject, so it's missing the cat, or I remember seeing that. So we need to find out what those images are and delete them. Okay, let's start from the beginning. Cat is there. Okay, so this one, to be honest, it's quite difficult to find a cat there. I don't really need to identify the cat there, so I'm deleting it. So let's start again, continue. Still have this one. Don't want to do it. Don't want to identify this cat. This hiding and there. Still okay. Very helpful. I thought I deleted it. Which one? It's not. Something is wrong with my window. First of all, it's not even showing me the pictures. And it keeps telling me that it deletes, but it doesn't. Oh, this is. Wondering if. Oh, this is a zip file. Okay. This no wonder. Okay, I need to do it from the non-zip file. Now I want to make things nice and big. You might find, you know, dataset cleanup boring, but that's actually, if you're doing data science, machine learning, data engineering, that's 90% of your time. That's you spend dealing with your data, making sure your data is good. And then the reminder is about architecture. But actually, many times you don't just, yeah, the architecture is nice, but not everyone is actually to that level, because the data is actually the most of the effort is in the data. Okay, I'm deleting stuff that, in this case, I really don't want to delete this, don't want to detect this cat. It's not really needed. This one is clear, okay? So I know this is a cat by looking at the picture, so the machine learning model should be able to do the same. We want to have the subject as unambiguous as possible because, first of all, it's a camera. It's capturing not just one image. We don't have just one shot of identifying an animal. We have hundreds because there's lots of, the camera itself can take 20 frames per second, right? So even if you don't detect properly in one frame, you can still detect in another frame when the cat is more clear. So okay, I don't have a lot of data now. I'll have to get some more. I think I have more. I just need to get it from the camera. And it's a lot of fun. Okay, so here the bird. Okay, this one is quite clear. You can see the bird. Okay, right. So let's just go and get more data. And I have to do the same thing I was doing the last time. I have to use VLC, and I use VLC to, when VLC is actually is an open source a video player, but it's very powerful, right? You can actually, there's so many options with this video player. And one of the options that I used just to save time, I could, I configured VLC to basically export every single frame of the video to an image. Actually, not every single frame. You can say, okay, I want only one frame every second and so on, right? And it's quite, yeah, it's quite nice. So we have a bird. Yes, where's our... Okay, let's go and find some wild camera videos. So, wild camera. So I have the wildlife camera videos now. Okay, so let's see. I think I need more cats and more foxes. To be honest, I'm going to start with foxes. It's more fun, and I have overall I have less foxes anyway. So I think I already did this video here. I'm going to do another one. Okay, so you see the fox. It's a different lighting condition, so it's actually quite nice to be able to use this one. Starting from almost the very beginning, so this is going to be useful. Okay, so I'm going to open this with VLC. Check. I think it's already going to be exporting to a temp folder. Hey, so someone is saying hi. Hi, Aman. Thank you so much. Okay, so we have. So I need to find. So in VLC, there is an option to export everything to export the video to images using a filter. Scene filter, I think. So the scene filter. So it's going to this directory, and now I just need to double check that the images are there. So the directory doesn't exist anymore. Wondering if it's video. I need to make sure this exists. We'd create a temporary folder here, which is going to be the folder where all my images will be going straight to. Okay. And then right now I'm capturing foxes, so I'm going to do foxes 3 or something like that. So I want to make sure it's a unique file name so I don't have to rename anything. And now I should be able to do play, and I should see the images being generated there. So I can just let it run until the end, and then I have suddenly dozens of images for testing or for validation or for training. I might end up having to use my own images for training because it's just so different from the actual data set you get on the internet. I don't know, but anyway, I will still try to avoid that if possible. But at the end of the day, I need this camera to work for my garden, right? And for my camera. Okay, so I have here all these images now. So I'm looking at your question, Aman, right? In which sense are you asking whether the cameras are going to get better in the future, right? Because are you talking about the Raspberry Pi cameras, which are quite poor, to be honest? Or are you talking about cameras in general? And while you refine your question, I'm going to continue my refinement of this data set. So let's see, view. I need to make sure this is big enough. Okay. What? This doesn't look like the same. Okay, yeah, so this one has Fox, the other one doesn't have Fox. So I'm going to delete this one. And this one, I'm not sure I want to identify. So I'm going to skip this one. It's too difficult. I couldn't tell. If I didn't know it was a fox, I wouldn't be able to tell from this picture one. So, and even this one is a bit, it could be a tiger. We wouldn't know. Well, okay, so the cameras that you get nowadays, they are very powerful, right? So if you look at some, there's cameras for all budgets, right? But there's some Chinese cameras which are, for example, HIK Sense. Um, they do all AI that you need to do. Like these cameras are very powerful. Not this one. What is it? I might be misspelling it. HIK Vision. Okay. So this is like they are not too expensive, and they have a lot of AI already embedded in them, and sometimes you're better off to just use the AI and just use the APIs that they provide, so you can implement whatever you need to do. The only trouble is when you want to do some very specific things, like for example, this wildlife camera where you have to detect. It's not you're not looking for intruders, right? You're looking for animals, right? Then if you're also talking about other types of detection, right? You can do almost anything. So the cameras are very good at capturing video, right? And to some extent, the AI is already very good. But what it when you say better, you need to kind of also specify what criteria you want to be better, right? Because from my point of view, if you have low light cameras that can actually see in the dark, like when I've there's like starlight cameras that without almost any light they can still see as clear as day. And I'm not talking about infrared cameras, right? I'm talking about just low light cameras. So yeah, but yeah, like when you're playing with the Raspberry Pi, you just have these cheap cameras. They are not very good. And I haven't played with drones, but it seems like you're also mentioning cameras from you. Do you have a DJI drone or something? Okay, let me continue. Before, okay, so I was doing the data set, and I gathered a few images. So I have enough foxes here. Okay, so this one. So from here I can delete it. Oh yeah. Yeah, so the ones that there are some really cool cameras that they can capture light in basically with very low light, yeah. And I mean, I checked out like some months ago. I checked the camera, which is very cheap. I bought it on AliExpress, right? But it was a low light camera, and I was quite impressed for a very small. It's a very tiny sensor, but it's very sensitive to light. Yeah, most cameras use Sony sensors, right? So you should check for. I'll put in the chat Sony Star. I think Starlight or something. I might be misspelling it. Let me just check. Um, Starlight. So these are very cool cameras, and I looked at these cameras because first of all, they are very sensitive to light. They don't need the infrareds, or if they need the infrareds, it's because it's like pitch dark. Yeah, and you can put them behind glass. which is quite cool, right? You don't have to put them outside. You can actually put behind your window, and because they don't need infrareds to see in the dark, then it because the infrared doesn't go through window or through glass, and you can even buy them on AliExpress or something. See, Starlight cameras. You can buy it like quite cheap, and you can play with them. And then you can connect maybe your Raspberry Pi to the camera itself with an Ethernet cable, and you can do some cool stuff with it. Right. So let me see. Um. So I'll just put this link for you. I don't know if you can actually, if I can actually put links. Okay, I'll just give you the name. You can search on AliExpress, right? Sometimes you will hear the name Sony Starvis as well. I think that's just search for those two and you'll find it. In regards to your question, Radzrek, um, sorry for mispronouncing your name, right? Radzeki, right? Regarding Python bots, yeah, I will probably do a separate stream, and I know people have a lot of questions on how to create Python bots, and yeah, so maybe I will come up with a separate session where I will answer those questions. All right, but today I'm doing this. So what I was doing, so the fox is not here, so I'm going to delete it. Okay, so no fox, no need to keep that image. Okay, so I have removed the pictures where the fox was not showing up, and now I only have, hopefully only have foxes. Oh, that sounds um in terms of what cameras to buy for your drone, to be honest, I wouldn't be the best source of information for that because I haven't built a drone myself. But it sounds very cool project that you have there. I would probably, yeah, yeah, I wouldn't be able to answer that. But depends also what you're looking to do with that camera, right? You just want to record things, or do you want to use some AI on top of it? Because I've seen that some people do. You can connect. You can connect like some. Well, a Pi is too big probably for a drone, but you can have like Google provides you with this TPU chip that you can connect, and you can have some extra power for AI. But I think that also needs. Yeah, I don't know. Depends on what your criteria is. it's very wide criteria that you can have for cameras, right? Are you interested in better image quality, or you care more about artificial intelligence? I don't know. Okay, so foxes. So I'm going to copy these foxes to my data set. Yeah, so suddenly, oh no, this is not, no, this is not what I wanted. Videos. So I can, getting lost in all these folders. What do I had, like, yeah, I need to go to VLC and find out. Video filters, scene filter. Okay, I don't know about you, but I always get overwhelmed by all the different windows and the different tabs in the browser. I get lost quite often. And I got lost here almost, thankfully. Oh, what happened there? Don't tell me. Don't tell me this folder is not there anymore. Hmm? It was there. Maybe I've done like undos or something, and that has messed up. I've lost my images. This is not great. Is that possible? I need to check my recycle bin. Yeah, I don't know how I ended up deleting my. Well, I definitely deleted some images, but I didn't delete the whole folder, right? Yeah, this was not today. Maybe very bizarre. I had. Anyway, it seems like I lost my foxes. She's quite annoying. I must have tried to undo and then it deleted instead. What? I don't know how that happened. Not happy. All right, so I'm going to try one more time and I'm going to call it a day or a night. It's a fox. I think this was the fox. Yeah, this one. In ML on Arduino. This sounds cool. What's that? Yeah, image quality. I guess you need to. I mean, you need to look at AliExpress. There's a lot of like companies from like Shenzhen in China. They are selling like components for cameras there, and you probably want to message a few of them, ask them some advice. You'll find so many things there. Almost someone will be able to give you good advice for that, and you'll find good quality cameras. Should have a directory again with images, and I can delete the ones I don't want anymore. But now this one is okay, this one is okay, this one is okay. I'm not going to be too fussy. Okay, do it from here. Do it, do it, do it, do it, do it, do it, do it. Okay, right. Even this one, I think I'll do it. Okay, this one is okay. I think it's finished. Okay, right. So now I have foxes here, and I'm going to copy properly without losing it anymore. Kaggle, dataset, testing, and I'll change the directory structure later as well. Okay, so I have more foxes here. Probably not enough yet. Need more. I probably need to spend a couple of more hours gathering more and more images. I only have 86 foxes. I need probably 500, as much as I can get. Because I'm not going to use this data set from my camera only for testing now. I'm going to use it probably for the whole lot testing, for training, validation, and testing. And I think I'm going to end the live stream. I'm sorry, I have to finish. It's already 20 past 11 here in London. It's a very hot day. I can't believe it. It's almost like if I'm in Singapore. This is the only place I can think of that I've been before that was this hot. It's like 30 degrees. It's 27 at the moment. And in uh, my room with this computer next to me, it's even warmer, I'm sure. So I hope you enjoyed this video. If you really liked it, yeah, don't forget to click the like button, right? That helps more people find it, right? And it helps me also, gives me a bit more motivation. And I'll see you again soon. Happy coding.